So writing software is complex not because of a tech stack or programming languages as we assume. It's complex because of us. We as a human, as a developer, make things more complex. By building application with a clean architecture, it gives us a feeling that we are building an application at a FANG level, which in reality we are not. The beauty of simplicity is that no one notices it. A great UX is when the user don't notice itself that it's a great user experience. Most developers who talk about clean architecture actually have never read the book. In this information age, we have a lot of information but very less wisdom. It's good to know that the tomato is fruit, but it's wisdom not to put in a fruit salad. Hello everyone. In this video blog, we are going to talk about clean architecture, complexity over simplicity. In this blog, we'll cover why developers are obsessed with clean architecture. Does it make our app simpler or more complex? What do we misunderstood about clean architecture, and what we should rather focus more on? So the reason why I wrote this blog post that because this is a last year blog post. Someone asked on Twitter that why developers are obsessed with clean architecture here, and this was my reply at that time, and it got quite of attention. So hence I thought of converting into a blog post. So the TLDR of this blog post is that people or developer always like complexity over simplicity because simplicity feels simple while complexity give a feeling that you have accomplished something meaningful. That's why developer create unnecessary architecture layer which we don't require, and clean architecture is one of them. Since we are going to talk about complexity or simplicity, the first question that we should be asking is that why is writing software is so complex? Now, writing software would have been easy if it were only written by machine. Since machine runs on logic, it's easy to understand and also predictable. But as we know that software is written by human, and human runs on feelings, and human feelings are one of the most complex things to understand. Even human itself doesn't understand where those feeling comes from. So we are so attached with our feelings that whenever something wrong happen in a code base or some bug occur, we first blame on the machine rather than ourselves. We either say that that bug is in the programming language, or it works on my machine, there might be some problem with your device, or the select is broken. But as we know that whenever we get a bug and we debug it, it's always us. We make a mistake in our code base and then we fix it. And still software is much easier to understand if it's written by, maintained by a single developer, a solo dev, or an indie hacker. However, those software are exception rather than norm. Broadly speaking, software is not built by just one person. It's built by a group of people. It's built by a team. It's more of a collaboration. So one thing people misunderstand, a developer misunderstand, that software is more sociological in nature than technological. Even if you are the only developer in the team, you still need to collaborate with CEO, designer, QA, who do not write code but impact on how you write code. This is similar to how a chess player and football player approach the game. A football player needs a lot of collaboration skill with other player compared to a chess player. Also, a football player relationship with their team player plays an important role on how well they will perform on the field. So writing software is complex not because of a tech stack or programming languages as we assume. It's complex because of us. We as a human, as a developer, make things more complex. Hence, more people involved in the project will leads to more complexity. Now, if we know the problem, then why we still make things complex? Why do developers love complexity? We have already established that human runs on feelings, and one of the most significant feeling that all humans seek is the feeling of importance. We want to feel important. We seek this feeling in various form by expecting praise from people, buying things, getting likes on social media, and creating beautiful Instagram reel. Ironically, I'm also expecting some kind of a praise from creating this video or essay. Now, what does this have to do with complexity in programming? Now, because of this feeling, most developers want to associate themselves with something bigger, something that make a big impact on the world. And FANG companies are representative of those impact. Saying I work for a FANG companies like Facebook, Amazon, Apple, Netflix, Google in your friend circle and peer group will give you a higher level of importance. No wonder getting into FANG course sells out so fast. However, most developers work either in a small startup or a service-based company, the majority of the developer. So we try to emulate that feeling by building applications similar to FANG companies in our app, influenced by their talk, blog post, and one of them is clean architecture. By building application with a clean architecture, it gives us a feeling that we are building an application at a FANG level, which in reality we are not. So for example, I'll give you an example. Here is the left one where we are using all new Dart, new features, pattern matching, records, and all that. And there is another code doing the same thing in a simple for loop. Which do you think is easier to read and maintain? The problem is that while implementing any solution, we miss the context. For example, dairy products are good for health in general, but it's not good for you if you are lactose intolerant. Those companies are giant with thousands of employees, as mentioned earlier. The more people you have, the more complexity adds. And this complexity justifies for them because they have a lot of people. Most of the complexity we introduced in our code base are not required. Instead, we should focus on simpler approach. Now, talking about simpler approach, why doing simple thing is not that simple. So let's try to keep it simple. In my opinion, there might be two reasons. First, we misunderstood easy with simple. And second, the most important one is that simple things don't get much attention. The beauty of simplicity is that no one notices it. A great UX is when the user don't notice itself that it's a great user experience. A great manager is the one where you feel that you don't need one. So let me illustrate with a code example. Let's say we want to show a message to a user on how many items we have added to the cart. And to make a message user friendly, we are going to use proper English grammar here. For 0 items, we should say no item found. And for any other number, we intend to show the number while maintaining the pluralization of word items. Like for example, no item found, 1 item found, 2 items found, and 92 items found. If I'm a junior dev and if you ask me to write a code, what I'll do is I'll write a code like this with a prefix checking with no number, then items for a pluralization, and then I'll concatenate the string at the end. The above example shows the message properly. The function concatenates the string message with some condition and it works. Now there is another version, a simpler version of this solution is this, that you directly check a number of that and directly pass the string message. For 0, you say no item found. For 1, you said 1 item found. And any other number, it's items found. And this also works. Now this function simply return all the full string based on the number using a switch case. Now which example do you feel is simpler and easier to read? It's the second one, because the first one is difficult to read and extend because they have a lot of condition, while the second one is simpler to read and easy to extend. And I know this example is very trivial, but the point I'm trying to make is that the simplicity of the solution. The first solution seems clever but complex, and the second solution is simpler but does not look clever. Hence, the developer always prefer the first one because it looks clever, which create unnecessary complexity. And the hard part about writing, simple code is that first you need to understand how the complex code look like. So basically it's a cycle you have to go through. You write a simple code and then you write a complex code and then you write again a simple code. So I really like this quote from Sandy, who basically says that you should not reach for an abstraction, but instead you should resist them until they absolutely instead being upon created. You should not, write the complex from the get-go. Start with a simple code and only make it more abstract and complex when it's needed. Now, what do developer misunderstood about clean architecture? You might think I'm, against, using clean architecture, but I'm not. Most developers who talk about clean architecture actually have never read the book. If you have read the book, here's the book. If you have read the book Clean Architecture, you will find that it's around 400-500 page long, And there is only one or two chapter which is dedicated to the famous clean architecture onion diagram. So what most developers do is that they only acquire surface level knowledge about clean architecture from a blog post or video or a courses. Nothing against them. They take the onion diagram as a blueprint and blindly started creating entities, repository, DTOs and so on in their project without understanding that the in-depth knowledge behind the clean architecture. The clean architecture is not about creating entities, use cases and DTOs. Rather it is more about separation of concern, creating boundaries, managing dependencies, solid principle, coupling, cohesion. And that is what this book, I mean, the 80% of this book basically talks about that. So what is happening is that in this information age, we have a lot of information, but very less wisdom. It's good to know that the tomato is fruit, but it's wisdom not to put in a fruit salad. Because of this, we build a lot of shallow knowledge, memorizing things, implementing them as they are, and missing the abstract idea, the deep knowledge. That's why clean architecture has become, escape hatch for developers. If you don't know how to make it work or you don't know any other pattern, you just use clean architecture everywhere. This is similar to how some people think that traveling the world would solve all their problems. Similarly, we think that clean architecture, MVVM, MVI, or any other new famous state management library will solve our code base problem. Okay, so if clean architecture is not the solution, then what we should do? What are the things developers should focus on? Simple one is that practice, practice, and practice. There is a 10K rule that suggests that in order to master any skill, you have to spend 10,000 hours of deliberate practice. Then only you can master that skill. Because no matter how many online courses you take, whatever article you read, whatever YouTube video you watch, or how many books you read, it won't matter until you put your damn finger and put it on a keyboard to write your code yourself. Until then, nothing works. That is, you cannot just get a six-pack app by just reading a fitness book. So focus on abstract idea and deep knowledge rather than fixating on a specific framework or a clean architecture or base state management solution or debating which programming language is superior. Focus on abstract idea or in-depth knowledge. Understand the principle like solid, cohesion, coupling, dependency management, separation of concern. Abstract thinking helps you identify similar pattern in any code base. If you do something in the front end might be similar to in a backend, something you do in a backend familiar in a front end. So try to have that abstract idea. Choose your learning sources. Don't limit yourself to only sources like YouTube, blogs, or courses. Read books, which I have wrote about a lot and also created a video about it. Read books for in-depth knowledge. Get a mentor, or the best approach is to build things yourself. YouTube will help you in the beginning, but over the time it will just won't have much value. Blog is just like whatever happening currently, it will keep updating it. Book is something when you start initially you won't feel that much of a value, but when you get more experience, the value of those reading books will compound. And obviously building things yourself is always on the top. So yeah, iterative learning with failure will give you a lot more deep knowledge than going through a tutorial step by step without any failure. So yeah, and learn techniques to transform code into any structure. Learn timeless technique like testing and safe refactoring. If you master these two, then you can transform any ugly code base into better structure or any architecture pattern you like very confidently. This skills allows you to make changes without fear or breaking things. By learning safe refactoring with safety net like test, you can navigate through any old legacy code base. Fifth is start small. Start by applying abstract idea from small places. Don't try to think a lot when you're starting out. Begin by doing it at the function level, how you can make a function better, then move it to the class level, then move it to the directory level, then after that move to a feature level, then finally consider the entire app level. Starting small and incrementally leveling up will help you grasp and implement abstract idea and principle very effectively. Also, if you make mistakes, small changes are easy to revert. This above point are main focus on whatever online classes I am running or workshop I am running. Flutter or any other framework is a tool to build something, but the real focus should be on the fundamental and the abstract ideas. But what if my app needs to scale? Can I avoid complexity forever? Honestly, I haven't worked on a FANG scale project, but I have worked on a few where we had a scaling issues. Most apps don't need as much as scale as we expect them to. When we talk about scale, we often think about FANG companies, but those companies are fewer in numbers. Most of them are startup or a service-based companies. I mostly work on front-end technology, and in my opinion, most scaling issue are back-end challenges compared to the front-end, because the front-end runs independently on the devices, whereas the back-end needs to handle multiple requests at once. However, there are cases when you need to scale on both sides. In that case, if you know the techniques I described above, then you can easily migrate your app to more scalable architecture. If you focus on right set of skills and concentrate on right things, you can essentially convert any app to be scalable. However, in my experience, we usually get it wrong when it comes to what to scale. So before you go down that route, make sure you measure and compare your solution before going live. So does that mean that we won't have any complexity forever? That is not true. Some apps are complex to build and maintain, such as banking, finance, healthcare, flight aviation, and so on. The point is to not avoid complexity altogether. It is to recognize the fact that most of the time we as a human introduce unnecessary complexity. Recognizing when complexity is essential and when it is self-imposed through our feeling is crucial. Yeah, so to conclude, writing software is complex because it involves human who runs on feelings. Hence, we should recognize this fact and not attach our emotion to the code we write. Rather, we should look for simpler solution by focusing on fundamental and abstract idea and learning techniques that help us transform any code base safely in small steps. So yeah, that's it, folks. Thank you. And if you like this video, then please like, share, and subscribe. Also, I have started a new workshop called Flutter with AI, where we just don't learn tools but learn workflows, which allows to ship us faster and avoid all AI related mistakes which cause hours of debugging time. So if you are interested, just click on this and fill up the form. And currently it's limited to only 10 participants. So yeah, thank you for watching. And if you like this video, then please like, share, and subscribe. Thank you.